Thank you. So before I start, I just want to say thank you for having me. And I mean, those in-person events are invaluable in making connections. And really thanks to Dory for hosting this and for gathering the speakers. And honestly, yeah, these in-person events are invaluable. And I'm really glad to be here and to talk today here. Okay, so now let's start. And you may have a minute to look at the picture and wonder what I'm doing. And so basically I like to cook, and what I'm doing is that I'm cutting what looks like a tree, and this tree will turn into, it's like cookable, and it turns into this white, this yellow arepa, and it's in Colombia, it's a Colombian dish. So basically, I like to cook. I like every cuisine, and how it's related to what I'm gonna say. When I cook, I like to use the best pan, the fanciest knives, and the reason is that I like to focus on the savor and extracting the flavors from the food, and focus on the dishes itself rather than the tools. And so when it comes to, I'm also an engineer, an AI engineer, and when I build something, I also like to focus on the business problem. And especially in data, and especially today, we need to focus on the problem we solve rather than the tools that we are using. And so today, I would like to show you how you can build your own AI-powered information retrieval system using one simple engine, and that has three methods covering all the use case for retrieval. And so it's going to be divided in two parts. First, we're going to talk about the framework, which is called the SIE, the Small Inference Engine, and then how I apply that to building a wine recommender system based on flavor profile, and I retrieve the wine flavors, and then I re-ranked, and also have an OCR-based extraction that matched the wine against the database. But we're gonna see that. So first, we're gonna start with the framework, which is called the Small Model Inference Engine. It is an open source tool developed by Superlink, which is a company that has built AI infrastructure for some time. And so before I talk about the engine, I just want to, so there's two things about that I want to highlight about retrieval system. Is that today, open source model, you have a lot of open source models that are available for a variety of use cases. And people often think that when you use open source, you lose some performance against proprietary models, but that's not true. Actually, open source models often catch up to the proprietary models within 3 months. So you don't lose any performance by using open source. And second is that when you use a model, when you run inference on one model using one GPU, you don't use all the resources of your GPU. So you have wasted capacity. So the SIE, the Small Model Inference Engine, provides an answer to this. So first, what is the SIE? It's an inference server when you can run lots of small models using in search and RAG system for a variety of use cases. So it's centralized behind one API, three endpoints, covering all use cases. So for embeddings, re-ranking, and information extraction. How it works? So first it mounts multiple models on one server. It loads them on demand by request. Then it queries the request for you. It batches the request for you. So which means that you fully utilize your resources, even if you switch models. And so, which means that you have predictable latency, predictable costs, because you use all your GPU. And because you can run multiple models, if you switch between models, you don't have to restart a service. You can really focus on the retrieval logic. So as I said, there are three primitives that are covering the retrieval use case end-to-end. First is embeddings. When you turn text or images into vectors, you can have dense, sparse, or multi-vector representation. So what you do is that you extract from some text or from unstructured data, you represent them as vectors, and then you have your first retrieval, which retrieve a set of candidates. Then, using the score methods, you re-rank. So you have your set of candidates, then using an encoder, you score each query candidate pairs, and then you re-rank your candidates, and then as a final output, you have your final re-ranked list, which is your recommended set of candidates. And then you have the extraction method, where you pull structured data out of unstructured text, like images, unstructured data, sorry, like images or text. So it can be used for name entity recognition, classification, etc. Invoice parsing, for instance. And you switch between all those use cases by switching the methods and changing one single parameter. You don't have to rebuild the entire infrastructure. So which means that you focus on building the product, and the SIE runs the model, runs the inference for you. You focus on gathering the right data, the retrieval logic, the business rules, the user experience, and then SIE handles all the inference layer, the model serving, the batching query, it optimizes the GPU utilization. So your app stays model agnostic, and SIE focus on the inference. So it applies to a variety of use cases where you need basically to match some information to a user intent. Like, again, add contextual targeting when you need to, or document processing when you process the invoice to extract the amount, for instance, when you need to extract some information out of unstructured data. Let's say you want to extract you want to identify something in an image. It also applies obviously in e-commerce search when you look for a product based on some attributes. Let's say it also applies when you need to classify some content. So let's say you have some user agentic content pipeline, so you have some content that is generated by an agent, and you want to flag the content, so you can use small models to classify the content into sensitive or not sensitive information, for instance. But also it also has some application beyond search, and what I want it can be applied in agentic systems today. And I wanted to highlight this problem because there's a problem called context rot, which means that basically the accuracy of LLM decreases as the context length increase. So even on simple tasks, there was a paper an article published by Chroma last year that shows that even on simple tasks, when the context length increase, the performance of LLM decreases, and it shows by the graph below. So as you have more tokens, the answers are getting worse. And it's not just about the context length, it's also about the position in the context. So when you have like the information in the middle of the context, the LLM response decreases, versus if the right context is at the beginning or the end of the context, then the LLM performance increases. So again, the position in the context matters. So all in all that to say that you need to pre-process your context, your inputs, before letting your agent reason. So, and that's where you can use also small models. You can embed the query, embed the documents, retrieve the documents, re-rank them to give to the agent the right context and the curated context to improve the response. Okay. So now, how I applied it to build another thing that I like, wine. So I applied that framework to build AI wine recommender system with the SAE. So with one catalog, so I pull all the data from a Vivino, which is an app that has all reviews and characteristics about the wine. I call it two flows that runs under one app. So the first flow is the wine recommender itself. So based on user preferences and wine profile, I do a first retrieval, then that doesn't use SAE, that retrieve the top 20 candidates. Then with the SAE, I re-rank the candidates and I put a final rank list. The second flow is, because when I talk to friends, they told me, it would be nice, sometimes you don't know the wine that you like, but you have a picture. And it would be nice to be able to upload a picture and to identify a wine. So I did that workflow, which when the user can upload a photo, and then I extract the information using the SAE extract methods, and then we match the extracted information against the database to identify the wine. So how does it work? So for the first flow, for the recommender itself, when I do something, when I make an app or a product, I like to replicate how it happens in real life. And in real life, the sommelier likes to think as wine as a wheel. So what you can see is that the wheel, when the most common flavor are at the beginning of the wheel, and the more you go to the extreme of the wheel, the more specific the flavor, the descriptors are. And so for the first retrieval, I try to replicate that logic. So I use the TF-IDF score. So the TF-IDF, basically it's a term, it allows for the term frequency, but it also allows for the scarcity, for the rareness of the term. So let's say that the term is very common, but it's widely used in the wine description. Then it's going to be scored. It's going to be scored high. But if a term is very rare and it's mentioned several times, I want to give a higher value. And that's what the IDF, the inverse document frequency, accounts for. So that's the first retrieval. I use the TF-IDF score, and then I rank the wine based on cosine similarity. And the goal of this first retrieval is the recall, is to narrow down the database of 5,000 wines into 20 candidates. And again, the goal is to catch a wine net and it's optimized for recall. Now, for the re-ranking part, we want to increase the precision. And for that, I used two re-ranking methods. First is the custom methods, where I use the encode endpoint of the SAE. And what it does is that it embeds each candidate wine, testing notes and reviews into an embedding. Then it embeds the user query into a vector, and then it re-ranked the wine based on cosine similarity. The second method is the standard method. It's a standard cross-encoder, when I use the SAE score method. And what I do is that I score each descriptor term and each candidate review, and then I re-rank them based on the average score of the candidate wine. It only works if the wine has reviews. But the bottom line here is that I have those two methods, and I want to see which one works best. And to do these two methods, I just had to switch. I just had to use encode and score. And it's the same 20 candidates, same API. It's an easy switch between one and the other. And so that's the main point I want to highlight here. You can really focus on which one worked the best rather than the infrastructure behind. And then the second flow is to find your wine from a photo of the label. So you upload the picture, you check for quality, and then you extract the text and the winery, the wine name, the vintage year with the extract methods. And then I have the matching logic where I match the extracted information to the database to identify the wine. The bottom line here is that I didn't have to focus on the number 3. I focus on the fourth part, the matching logic, which enabled me to improve the matching rate between the photos and the database. So again, all in all, you have 3 things to remember from this talk, is that from one engine and 3 codes that cover all use case for retrieval system, you can build your own information retrieval system. You own the retrieval logic. You can focus on the retrieval logic by using the same API, different methods. All the infrastructure, the batching the requests, etc. are managed for you. You can focus on the product and on the retrieval logic. So now, if you want to build your own version of the sommelier, I invite you to scan the QR code. You can access the GitHub repository and check it for you. And if you have any question about using the DSIE, feel free to ask me after the talk. Thanks.
Awesome.